proceed. All right, now let's go on to video number 2. Now, this is graphically here. You've got a graph here. The first one, A here, another one, another one, another one there. So they have to give you a limit. So the graph has been drawn. It's y equals to x. Now, on the x-axis, we've got point C. So we're going to have to determine, let's say, limit of that, of that equation. All right, when x approaches point Z. All right, so maybe let's call that equation, well, it's y. Well, I'm just gonna call it, I'm in bracket, I'm gonna put it y, but I could have put it as f of x. So what do we do? You need to go along the x-axis because C is actually on the x approaches Z. That's why we're going along the x-axis, because we're saying x approaches C. We good?
Yes.
Then we identify where that value C is found on the x-axis. Then we need to approach that C coming from its left-hand side and also coming from its right-hand side. Are we together?
Yes.
All right. That is more like a sandwich theorem. Actually, it is. Now, let's approach from the left-hand side. If you are coming from this left towards the C, that's what we say as x approaches or tends to C. But it will never have to touch C. It just gets closer. Now, if I do it as point, let's say I'm now here where there is a red dot. On the red dot, I just need to locate where the graph is. The graph is going to have to be above the red dot or below. It's a blue line. So that means I just go above and identify and touch the graph and get the corresponding y value. I'm just going to call the letter A. So the y value will be there at A. We agree. Am I right?
Yes.
When I go further down, I'm going to make it black here. Now, there is a new dot. That new dot, you see, it's approaching C, the black dot. So where is the graph? I'm going to look above or below. The graph is above, so that means when I touch the graph here, the y value will be read here by point B. Okay, can you see? Is it making sense to you now?
Yes.
All right. Then we do the same thing. Then we say, okay, guys, as we get closer, let me see which color I'm going to go for. Purple. When we get here, there's a purple. Then I check up and below. Where is the graph? It's above, just above there. So there, and then we'll read the value there. I'm going to call that one K. Are we happy now?
Yes.
Now, to simplify the whole story, from red dot to black to purple, so that means as I'm going towards the right-hand side, meaning towards the C, coming from the left-hand side, normally we write it like this. As x approaches C, we put the power of negative right at the top, meaning I'm coming from the left-hand side of Z. We good, right? Yeah.
Yes.
So what happens to the y value? They move from A to B to K, which means the y value goes upward like that. They're going towards that point Z. Can you see that?
Yes.
Aha. So we can write it in this manner. I can say limit, because it's a left-hand side limit. That's what we call. As x approaches C from the left-hand side of that equation y, our answer becomes Z. The y value gets closer to Z. Now, left-hand side and the right-hand side limits must be the same, listen to me, in order for the limit to exist. We good?
Yes.
Yeah. So remember, this is an approach from the left-hand side. Then the approach from the right-hand side, I'll write it in purple. So we're going to write limit as x approaches C from the positive, from the right-hand side of C. What will be the answer? If the answer of the black and the purple are the same, that answer will be the limit one. If they are not the same, the limit does not exist. Yeah, it's like saying left-hand side must be equal to the right-hand side, basically. Yeah.
Yes.
All right. So I'm going to use purple. So as we come closer in this direction, you see, you have to identify, if I put a purple dot here, you have to look above it and below to check where the graph is. Well, the graph is way above. It's here, right at the top. The Y value will be here. I'm just going to call that one R. Once I bring it closer, because now we're coming this way, when I bring it closer here on the red dot, where is the graph? It's just above me, and I'll read it there. I'll just call it M, by the M. So now you can tell as X approaches C from the right-hand side, the Y value, it starts from R going downwards towards the M in that direction. Are we happy with that?
Mm-hmm.
All right, so I'm going to remove all the mess. So I'm going to color code them now. The red, it's approaching coming from the left, and then the Y corresponding will be the red line. And then the purple is coming from the right-hand side. The corresponding on the Y, it's actually that one there. So you can actually see these two guys here where I'm circling. They are both getting closer to C. Yes. So therefore, the limits exist. So now you can conclude. You can now write it this way. Limit as X approaches C. You no longer put positive or negative. We good, right?
Yeah.
Of that equation, Y, the answer will be C. Or maybe before you put that down, maybe before you can put that down, what's in the box? What you can do, you can just tell them, guys, listen, guys, the limit approaching C from the left-hand side, from the negative, it is equals to the limit approaching C from the positive side, and the answer equals to Z. Therefore, the limit at Z, it has to be that value C. You got it?
Yes.
All right. Yeah, that's the story. That is graphically